Hello everyone, I'm Sijia from University of Maryland School of Medicine. Today I'm going to talk about the feasibility of targeting mesial temporal lobe structure using transcranial MR-guided Fox ultrasound. Thermal ablation in the brain with transcranial MR-guided Fox ultrasound has been FDA approved for the treatment of essential tremor and Parkinson's disease by using a clinical system which has 1,024 ultrasound transducer elements. So it can provide a very accurate targeting, and it can raise the target temperature rise up to 50 to 60 degrees Celsius. But its use in treating temporal lobe epilepsy has not been well explored, mainly because of the target location, which is the mesial temporal lobe, and it is quite close to the skull. In this case, it can potentially cause low energy transmission efficiency and skull heating. Also, mesial temporal lobe is a relatively large target compared to a single target in the thalamus in the treatment of ET or PD. So in this study, we come up with a few methods that can potentially improve the targeting in the treatment of temporal lobe epilepsy, which includes we will try low frequency ultrasound, low duration and low energy sonications. Also, we will do controllable multiple spot sonications to cover the mesial temporal lobe structure. And we will first do acoustic and thermal simulation, and we will do experimental validation on ex vivo skulls. We first perform the acoustic simulation with lower frequency ultrasound, which is 220 kHz, compared with the clinical 670 kHz system. We found that with the 220 kHz system, it requires a much higher power to reach the same temperature as the 670 kHz system. And around the mesial temporal lobe structure, the acoustic pattern was quite scattered, which is not ideal for thermoablation purpose. So we decided to move forward with the clinical 670 kHz system. Then we did a simulation with three different sonication models. What you see in the figure is the estimated thermal dose from the accumulated equivalent minutes 43. Here we are basically trying to compare the sonication mode, which has a peak temperature of 60 degrees for 16 seconds, which is typically used in the clinical treatment, with a peak temperature of 50 degrees, but the duration is 60 seconds. We found that even with a peak temperature of 50 degrees, it is possible to create an effective lesion. Then we move forward with this sonication model. We calculated roughly a 6 sonication would be needed to cover the mesial temporal lobe structure. We then did experimental validation on 3 ex vivo skulls. The target temperature rise was measured using MR thermometry, and the skull temperature was measured using thermocouples at the skull heating location predicted by the modeling. From both simulation and experiments, we found that it was able to achieve 50 degrees on 2 of the skulls, and it was a little bit lower on the other skull. And while maintaining the skull heating below 10 degrees. And it was done on the locations which is very close to skull. If we move the target, if we move to a more superior target, it was actually easier to reach higher temperature with lower skull heating. In conclusion, through both simulation and experiments, we have demonstrated that it was possible to heat the mesial temporal lobe structure to 50 degrees, which can lead to a sufficient thermal lesion without having the skull heating more than 10 degrees. And we have some other methods under development which can further reduce the skull heating, including blocking certain transducer elements, and also with the implementation of the cranioplasty windows. Thank you. I would like to thank the funding resource and the support from both the clinical team and the research team on this project.